Welcome dear students. Let us talk about the IUPAC nomenclature of the carboxylic acids. Dear students, the simplest hydrocarbons are alkanes. If you will replace hydrogen of alkane with a functional group which is the carboxyl group, the carboxyl group is written something like this. This is the carboxyl group. So replacing the hydrogen of alkane with the carboxyl group, you will get a class of the organic compounds which in common language are called as the carboxylic acids. So basically carboxylic acids are the derivatives of the alkanes. My dear students, this portion that is the active part of the organic compound, it is called functional group. And this portion, it is usually a hydrocarbon portion. Of organic compound if there is no substituent other than alkyl groups is attached. Carboxylic acid is the common name of this class. Now what should be the general IUPAC name of this class? That is taken from alkanes. My dear students, this E of the alkanes, that will be replaced by OIC acid. So at the place of this E, you will write OIC acid and then you will get the name alkanoic acids. So the common name of this class of the organic compound having this functional group, that is the carboxylic acid, and the systematic or IUPAC name of this class of the organic compound, that is the alkanoic acid. And this word alkanoic acid is basically taken from the alkanes replacing the E with OIC acid. It means simply we can say that the IUPAC names of the carboxylic acids will be derived from the IUPAC names of the corresponding alkanes. A carboxylic acid having one carbon atom, that will be having IUPAC name according to the alkane having one carbon atom. Similarly, the name of the carboxylic acid with two carbon atoms will be taken from the IUPAC name of the alkane with the two carbon atoms. So let us now take some examples. Starting from the simplest carboxylic acid with one carbon. You know that the alkane with one carbon atom is called as methane. So the carboxylic acid with one carbon atom after methane, that will be called as methanoic acid, replacing E of the methane with OIC acid. Similarly, the carboxylic acid with two carbon atoms, after ethane, its name will be ethanoic acid. And the carboxylic acid with three carbon atoms, after propane, it will be called as propanoic acid. In the same way, with four carbons, it will be after butane, butanoic acid. One with the five carbon atoms, after pentane, that will be called as the pentanoic acid. And in the same way, carboxylic acid with 6 carbon atoms, that will be called as hexanoic acid. Now, these are the carboxylic acids from carbon number 1 to carbon number 6, and they are all non-substituted carboxylic acid, means there is no substituent attached with these carboxylic acids. Now, if we have some substituent attached with the carboxylic acid, then what should be the naming, IUPAC naming of those carboxylic acids? Now, let us discuss the substituted carboxylic acids. My dear students, in case of substituted carboxylic acids, the rules are same as we generally apply on all the organic compounds. The first one is selection of parent chain. Parent chain means the longest chain of the carbon atoms with maximum number of substituents. That is called as the main chain. It is also called as the skeletal chain or parent chain. After selecting the parent chain, the second step will be to allot the numbers to all carbons in the parent chain. In case of carboxylic acid, remember this point that is very important, that the carbon of the carboxyl group, that will always be first carbon of the chain, because carboxyl group is the functional group which is always present at the terminal of the chain. That's why the carbon of the carboxyl group will always get number 1, because in case of numbering, we firstly prefer the functional groups, mean the carbon of the functional group should get lowest number in the main chain. After numbering, then the third step will be naming. Now, in the naming, again, you will mention the position of substituents, and you will also write down the names of substituents in alphabetic order. And if 2 or more identical substituents are present on the different carbons, their naming will be like di, tri, tetra, like this. Now, let us take some examples so that this concept may be cleared. Now, this one is a carboxylic acid with 6 carbon atoms. Let us complete the valency of the other carbons. It is basically hexanoic acid. If we attach substituent here, methyl, and one methyl is attached with this carbon. Now there are 2 substituents, so it will be a substituted monocarboxylic acid. Again, first of all, you will select the longest chain. Starting from this 1, 2, 3, 4, 5, this chain has only 5 carbons. 1, 2, 3, 4, 5, 6. This chain has 6 carbon atoms. 1, 2, 3, 4, 5, 6. The straight chain also has 6 carbon atoms. So it means there are different chains, but the maximum possibility of the carbon atoms, that is 6. So you can select either this chain or the straight chain. So let us select the straight chain of the carbon atoms as the parent chain. Now numbering, we have already discussed that this carbon will always get number 1, 2, 3, 4, 5 and 6. The carbon of the functional group, according to the rules of the IUPAC, must get the lowest possible number. So here the carbon of the carboxyl group will be having numbering that will be equal to 1. After numbering, now let us name. There are two substituents in this carboxylic acid, and both substituents are same substituents which are present on the different carbons. So you will not write down as 4 methyl 5 methyl hexanoic acid. This one will be the wrong name of this carboxylic acid. When the two substituents are same, their position will be mentioned like 4, 5. There will be comma in between these two numbers. And there are two methyls, so you will write down dimethyl. And how many carbons are in the carboxylic acid? 6. So according to hexane, that will be called as hexanoic acid. So that will be 4,5 dimethyl hexanoic acid. Now, my dear students, let us take some more examples. Like if we have this compound. Now it is again halogen substituted carboxylic acid. The longest chain will be, no doubt, the straight chain. It will be carbon number 1, carbon number 2, and carbon number 3. So its name should be, first of all, you will mention the position of the substituent, that is 2, because it is attached to second carbon. Name of the substituent, that is bromo. And how many carbons are in this carboxylic acid? 3. So after propane, it will be propanoic acid. And its IUPAC name will be 2-bromo-propanoic acid. Similarly, let us take some more examples. Now this one is a carboxylic acid in which there are different types of the substituents attached. First of all, let us select the longest continuous chain of the carbon atoms. 1, 2, 3, 4, 5, 6. This straight chain has 6 carbons. 1, 2, 3, 4, 5, 6, 7. This chain has 7 carbon atoms. So you will select the chain with maximum number of the carbon atoms, and in this case the skeletal chain or main chain or parent chain will be something like this. Now you will allot the numbers. Obviously the functional group will be preferred: 1, 2, 3, 4, 5, 6 and 7. Now after giving numbers, now let us name them. Now there are 3 types of the substituent: chloro, bromo and methyl. When you have different types of the substituents attached to the main chain, then their naming will be followed in alphabetic order. Now we have bromo, chloro and methyl. So alphabetically, bromo should be given the first name. So it is attached to carbon 4. We will write down 4 bromo. Now second one alphabetically, that will be chloro, attached to third carbon 3 chloro, and then with respect to alphabetic order, methyl should be at the end as it is starting with M. So it is 5 methyl. And how many carbons are in this main chain? 7. So the alkane with 7 carbons is called as heptane. It will be heptanoic acid. So 4 bromo, 3 chloro, 5 methyl, heptanoic acid. That will be the IUPAC name of this carboxylic acid. So I have given different examples in which sometimes the substituents were same, sometimes the substituents were different, sometimes there was only one substituent attached with the parent chain. I hope so that giving these examples and you will be quite understanding this, that how we can give the IUPAC naming to any carboxylic acid. You can practice some more questions by yourself, and if you find any problem during practicing of the different names of the different acids, you can ask in the comment section. I will help you out in practicing the more names of some more carboxylic acids. Till then, take care.